So number 1 says, given the following equation, Al2SO33 plus 6 NaOH gives me 3 Na2SO3 and 2 AlOH3. So they're asking me if I start with 384 grams of aluminum sulfate, so this stuff here, and I isolate, meaning I've acquired after my reaction 212 grams of sodium sulfate, what's my percent yield? So in other words, I should expect a certain amount when I do the lab. I actually got 212.4 is my actual yield. So let's go ahead and work this out. Actually, I'm going to try something real quick. See if I can copy this over. Oh, it actually worked. Wow. That's handy. Because now I don't have to keep switching back. So, what I'm going to do is I am going to start with the stoichiometry. So I know I have 389.4 grams of Al2SO3 and I want to, my goal is to figure out how many grams of Na2SO3 I should produce. So hopefully we're starting to see this pattern. I go into moles, so I'm going to divide by molar mass. So can somebody tell me what my molar mass of Al2SO3 would be? 2 aluminums, 3 sulfurs, 9 oxygen. SO3, 3. $294. Here, let me look it up real quick. You got that too? So I like the confirmation there. So you said 294 grams of Al2SO3 for 1 mole. Sounds good. All right, so then so I go into moles and then I use my mole ratio. What's my mole ratio between what I want and what I have? So 3 moles of Na2SO3 for every 1 mole of Al2SO3. You guys good so far? We went into moles and then used the mole ratio. And then our next step is to go out of moles. So then I'm going to take times grams. So now I need a molar mass of Na2SO3. Anybody get anything? This is E. I get 126. Let me double check that. Sodium. Yeah. Sodium's 23. So 23 times 2 is 46. Sulfur is 32. And then 3 oxygens would be 16 each, so 48. So 48 plus 32 plus 46. Is it? Okay. Does that make sense? How we did that? Do you get 126? Anybody else get one? All right. So 126 grams per mole. No worries there. So we'll do 389 on my calculator. Let's take 389.4 divided by 294 times 3 times 126. I get 500.7. Now, do we understand why would I calculate that? What does this number tell me? 500.7 grams. We have a special name for it. It's my theoretical yield. Is that good? You got 389 is what I started with. My yield is on the product side, the 212.4. So my actual yield, whoops, 212.4 grams. Actual yield. So I wrote it above because my percent yield is the quotient when I divide 212 divided by 500.7. So 212.4 divided by 500.7. I get 0.42 or 42.4%. And that's my percent yield. So any questions? So now let's go ahead and look at number 2 on the 90 homework. We are going to start with 50.3 grams of aluminum hydroxide. And we're going to isolate in the lab 39.5 grams of aluminum chloride. So is that my theoretical yield or my actual yield, the 39.5? It says you isolate. Well, theoretical is what we have to find using stoichiometry. Yeah, this is what I actually got in the lab. I know it's tricky sometimes getting those terms straight. But the number I'm going to start with, because we know we started with 53 grams of aluminum hydroxide. We can figure out how much aluminum chloride we should have obtained using stoichiometry. So first off, I need molar mass of aluminum hydroxide. I get 78 grams per mole. And then I need to use my mole ratio of what I want to acquire. So, see that 1 there, that 1 implied there. So that's my mole ratio between what I want to get and what I have. So what I want is aluminum chloride. What I have is aluminum hydroxide that goes on the bottom to cancel everything out. So now I'm in moles, but my actual yield is given in grams. So I have to go all the way into grams. That's where I multiply by the molar mass. And with aluminum chloride, guys agree that that's all 133? 133 grams per mole. Good. I already know that that's right. I agree with that. We'll look at how to get there. So 50.3 divided by 78 times 133, because I don't need to do times 1 over 1. I get 85.8 grams of aluminum chloride. That's my what? Theoretical yield? Actual yield? What's this number telling me? Yeah, stoichiometry gives me the theoretical yield. Thank you. Because my percent yield is actual yield, which is up here, over theoretical yield. 39.5 over 85.8. And like we said, the percent, 39.5 out of 85.8 comes out to be 46.0%. So good job. Is there anything we have questions on there? All right, so try those ones on the first page, and then with the second page, these are basically the same problems. It's just there's an additional step with the limiting reagents there. So we have here in part A, they're first going to ask us to find a limiting reactant. So let me pull this one over. So we have NaCl and H2SO4 gives me NaHSO4 and HCl. It is balanced. So we have 10 grams of sodium chloride and 12 grams of sulfuric acid. So it's going to look like this, 10.0 grams, 12.0 grams. So I combine those. I need to figure out which one is the limiting reactant. So what I have to do, notice they're in grams. The only way I can compare two substances to one another is if I put them in moles first, which I know is kind of annoying, but what that's going to do for us is it's actually going to complete the first step of the stoichiometry part. So I'm just going to write NaCl compared to H2SO4. And we need some molar masses. The NaCl, we've got 10 grams. We need to convert that to moles. And we've got H2SO4 is 12 grams. We have to convert that to moles. Thankfully, these are on the board. So you can see there, NaCl is 58.4 grams per mole, according to the last class. And H2SO4 is 98 grams per mole. When I divide those out, I get 10 over 58 is 0.17 moles of sodium chloride mixed with 12 divided by 98 is 0.12 moles of sulfuric acid. So combined with the 0.17 moles of sodium chloride. Looking at that, what we want to do next is divide by the coefficient. Now, here the coefficient of both of those is 1. So I'm just going to divide both of them by 1. I get 0.17 and 0.12. Comparing those two numbers of moles based on their coefficients, which one is my limiting reactant? Which one do I have less of? Yeah, the bottom one. So that's why you can't go by grams, because I had more grams, more weight of H2SO4, but that means I had less moles for the reaction to happen. That also tells me that NaCl is in excess. So which number, do you guys know which number I want to use to do my stoichiometry? So for part A, we're saying H2SO4. Do I use that number to do my stoichiometry, or do I use the excess number? So I sort of worded it that way, see if I could. I kind of favored the excess number, but no, it's actually, we want to use the limiting reactant because remember, when you're building the bikes, you're building the cars, you're building the sandwiches, you want to use what you're going to run out of first, right? Because if I have 3 pieces of bread, and I have excess cheese, I can only make 1 sandwich, right? Because I run out of bread first. So that's why we want to go with the limiting reactant. I know it's tempting to go with the excess, but yeah, the limiting reactant is kind of our weakest link that's going to limit how much we actually get. So let's go with the limiting reactant. We already converted it into the moles, so we're going to have 0.12 moles of H2SO4. We want to figure out my theoretical yield of hydrochloric acid, so the HCl. I'm going to use the mole ratio, which is just still 1:1. So 1 mole of HCl for every 1 mole of H2SO4. So I went in the moles, used the mole ratio. Now time to come out of moles. HCl was 36. Did you need to? Yeah, you can go. 36 grams per mole. So we're just going to take 0.12 times 36 is 4.32. That's my theoretical yield. Something strange happened, though, in my percent yield. I actually wind up with more HCl than I was expecting, so something must have been contaminated to make me think that I had more, or way more. So I'm still going to take my actual yield divided by my theoretical yield. So 4.45 grams divided by 4.32 grams. And I'm going to get a number over 100%, which is still something possible in the chem lab. You might weigh it out and be surprised because you didn't fully react it or something. So you get 103% for this one. So strange, but can happen where you have a percent yield greater than 100%. So for part B, my theoretical yield was 4.32 grams of HCl, and for part C, my percent yield was 103%.